Hi! So in this video, I'm going to talk about how to create secure random numbers in Python. So many people who know about Python know about the random module. And the random module is used for creating random numbers, but this is not applicable for creating random numbers used in security. For this in Python, you typically use a model called secrets. So let me quickly start by explaining why some random numbers are useful for cryptographic applications while others are not. So let's start with a random number generator. This is what we want. This is some kind of process by which a sequence of numbers are generated, and specifically that cannot be reasonably predicted better than by random chance. So you generate here a sequence of numbers, and you cannot really replicate or predict the new number any better than random chance. Say that you're creating numbers between 1 and 10, then before getting the next number in the sequence, you cannot predict it better than by 10% accuracy. And you might think, isn't this what, for instance, the standard functions in the random module does? And that's not actually the case. So in the random module in Python, you get what's called pseudorandom number generators. This is an algorithm for generating a sequence of numbers, so far so good, but whose properties approximate the properties of sequences of random numbers. So they are super useful in statistics, machine learning, they're super useful in game design, but they're not intended for cryptographic properties. In fact, for most of these pseudorandom number generators, if you know the seed, so essentially the starting point, you can calculate all further numbers. So they're not really random in the true sense, they're simply kind of approximating something random, but you can easily figure out what the next number will be if you know what algorithm is used and the initial starting point, called a seed. And in some applications, like machine learning and statistics, having this predictability is super useful, because that means that someone else can essentially replicate your experiment because they know the starting point that you've given to them, and then they can do the same things as you did and get the same result. So pseudorandom number generators are super useful in their own fields, but they're not at all intended for cryptographic applications like creating passwords. So now let's head into VS Code, where we can look at the secrets module in Python for creating secure random numbers. So here we are. I've just have some pre-made comments here. We can start by importing secrets. It's part of the standard library, so you should have this installed if you have Python installed. Let me first just show you some of the most basic useful methods. One of them is going into secrets and then using token bytes. So token bytes will simply give you out the number of bytes you request. As simple as that. So let's do 16 and let's print that out. Let's call this just random byte string. Have some nice formatting. Print it out. And here you can see that this here is what you get. So here you have a byte string. It's of type bytes in Python, and this has been created for you in a secure manner. So there are two other standard methods that are pretty useful in this module. Another one is secrets, and here you can see a lot of them. I'm thinking specifically about the token hex, and as you can see here, if I hover over it, this returns a random text string but in hexadecimals. And again, you can pass in the number of bytes. So if you recall, a byte consists of 8 bits, so that makes 256 combinations, and you can combine that into the product of 2 hex digits, because they have 16 digits each, so that's 16 times 16, that's 256. Let's do 16. And again, let me wrap it in something similar just so we can see the difference. But here I can write random text string in hex. And here you can see it. So since I wrote 16, you'll get 32 hex symbols here. Finally, we can also go into secrets and we have something called URL safe. We can take a look at this. So this returns a random URL safe text string in base 64 encoding. So again, it works the same. You pass in the number you want. Let me again wrap it in nicely. Let me call it random URL safe text string, like this, and run this. And here you can see the output. And you've probably seen text strings like this. For instance, when you need to reset a password on a website, they will sometimes send you a specific URL that has such a random string randomly generated at the end of it. And this is of course so that other people can't access this specific URL easily and then just reset your password to something they choose. How you typically use this URL safe then is you can make something like a recovery URL variable. And here you can have some HTTPS, and then let's call it myawesomesite.com. And then it's pretty common to call this reset as a query parameter and equal to what you generate. So here we can do secrets.URL safe. For instance, 16 is pretty common. And then if we print this, then you can see here that you get this type of link that you've probably seen previously. I also wanted to show you how to generate passwords. This is a very common task. And one way to do this is to take a combination of uppercase and lowercase letters and digits and then pull out a sample of them. So one way you could do this is to manually type in all the letters. That's a bit cumbersome. So what you can do in Python is just to import a string library, because in the string library, you can go to string and then you can do, for instance, ASCII letters. That gives you all uppercase and lowercase letters. And then you can add to that collection the string.digits. You can also, of course, add more symbols, special characters, and so on. But let me just call this my alphabet. So I'll make my password out of this. What I'll do is to go into the secrets module and here create the system random class. So I'll call this secrets generator like this. And if I access the secrets generator here, I have loads of different methods here that I can choose from. I think I'll just do a sample. And a sample, as you can probably understand, simply selects a sample from a given collection. So then I will take this from the alphabet and I want 16 of them. Let's print this out. As you can see, it looks kind of random, but it's in a bit of a wrong format. So it's a list of individual strings. So if you want to convert this in Python, what you can just do is to make an empty string and then join on this whole thing here. You do that instead, that gives you this as a nice string. This looks like a pretty random password, and then of course you can assign this to a new user. When actually doing password creation for, say, users, there are other things you need to be aware of. For instance, something called salting. I don't want to go into this because I don't want to pad out the video too much with different things, but just know that password generation is a very serious topic and you need to take great care when you're doing it. So these are some of the basic things you can do with the secrets module. At the end, I just wanted to go over to the documentation page and show you some other nice features. So here it is. This is the secrets module. It's pretty new, so it is in Python 3.6. Here you can see the related PEP506, which is basically the introduction of the secrets module. And then also you can see here the system random that we use and some other nice functions like choice, rand below, and rand bits. And here you have the three functions that we went to, the token bytes, token hex, and URL safe. One thing I wanted to mention is that if you go a bit down, there is also this other function. This is compare digest. So this takes in strings or byte-like objects, and it returns true if they're equal and otherwise false. This might sound like, wait, isn't this just like the double equal sign in Python? And kind of yes, but also no. It does the same result, but as it says here, it uses a constant time compare to reduce the risk of timing attacks. So timing attacks are basically cryptographic attacks where you try to find out, for instance, a password of someone by essentially guessing a lot of times in a clever way and then using statistical properties of the checking algorithm to understand if you're getting closer. So the intuition here is that if the strings are completely different, then usual evaluation in Python will just reject it very quickly, saying, yeah, these aren't equal, but you can use that information to gradually get closer to the real answer. So it tries to use the same amount of time independently of how different or equal they are, and that makes it so the timing attacks doesn't work. A final thing I wanted to say here is that you can see here that it says you can just go to the hmac.compareDigest for this. So this is really just a reference to that method. And also if you go up here to the system random, then you can see that this is really something that's within the random module. So you can go here, and here you can see that it uses the operating system module to really get the random numbers. So if the system random class is just fetching something from the random module and the compare digest is just fetching something from the HMAC module, then what's really this module doing? And the answer is kind of not a lot. Everything that we have in the secrets module, it's really just fetching the correct pieces from the other standard modules in Python. So some people have a bit negatively called it the most useless module in Python because it's really just pointing to stuff in other modules that you already have. But still, I understand the reason for implementing this and I think it's pretty useful. This is described in this PEP506. And if you look at this and go down to the rationale, you can actually see why this was introduced. And the first sentence encapsulates this. The proposal is motivated by concerns that Python's standard library makes it too easy for developers to inadvertently make serious security errors. So the module is really just an interface in some sense where you cannot really screw up that easily. And I also really like this. The first hit when searching for Python how to generate passwords on Google is a tutorial that uses the default functions from the random module. And as we've talked about, that's a pseudo-random number generator that's completely non-secure. So this is really about guiding users that are not super comfortable with Python towards a more secure solution easily. So I think this is most of what you need to know about the secrets module in Python. If you want to learn more, then of course you can look into the documentation and also the PEP proposal. I hope you found this useful, and I'll see you again later.